talk about what this statistical property 3 really mean, okay? We will always have some unknown population parameters. What are some of the unknown population parameters that we will have in this course? Population parameters. What are some population parameters? Yeah.
Beta 0 and beta 1.
Beta 0, for example, and beta 1. Once we go to multivariate regression, we'll realize that there is beta i's, right? That we could have as many betas as we like. What else are there that are parameters that we don't know? Betas, yeah.
The true value of the error term.
We don't know the true value of the error term. Now, true value of the error terms are not actually parameters, okay? But are actual, realization of a random variable. Okay, we know that this epsilon is a random variable. And just do it out here. This epsilon is a random variable, which we will assume certain things about this epsilon, okay? One thing that we can assume is that it's normally distributed. Another thing that we can assume is that it's centered around or has an expectation of 0. Another thing that we can assume is that it has a constant variance, okay? So if you assume that it has a constant variance, or you have homoscedasticity, then this will also be a parameter, okay? For each of these unknown parameters, we're going to have some estimators, okay? So these estimators are going to try and sort of like make a prediction on what the true parameters are effectively, okay? So you're going to have estimators, and with estimators, we're going to put hats on them, right? And just like this beta are population unknown parameters, this is also an unknown population parameter, okay? So I might want to try and estimate this, right? What is the variance of the true population error terms, okay? Now, these estimators will have properties. Some desirable properties might be things like unbiasedness, right? Unbiasedness. What is unbiasedness? It means that the expectation of the estimator, these estimators are random variables. Random variables. In what sense? Every time you change the sample, you're going to get a different answer, right? So they're random variables. So I'm going to also have, in the case of statistical property 3, I'm also going to have some estimator for this. The properties of the estimator will very much depend on what? What will determine the properties of the estimators? What will determine the properties of the estimators will be?
Sample size?
The sample size will of course be one of them, right? Possibly, but not. So the sample size will determine the behavior of the estimator, will not necessarily determine the properties of the estimators, okay? Of course, the sample size will determine how you're going to go about calculating this and what these values would be, but it will not necessarily determine that an estimator is unbiased or not, right? You could have a sample of 100 and have an unbiased estimator, or you could have a sample of 3 and have an unbiased estimator. What will determine the properties of estimators? What is one very important part that will determine the properties of these estimators? It must be the assumptions that you make on the model, okay? So the assumptions, of course, will heavily impact these properties of the estimators. So when you talk about mechanical properties, you don't have to make any assumptions because those are mechanicals. That always happens when you do the OLS, okay? When you talk about statistical properties, you cannot just say, I'm just going to remember what statistical property 2 is and what statistical property 3 and 4 is. Because you also have to remember under what assumptions are those statistical properties valid, okay? For mechanical properties, you didn't have to do that. But for statistical properties, you cannot just memorize, statistical property 2, 3, 4, 5, 6, whatever. You have to ask yourself under what condition. So for example, it could well be that this variance parameter has an I on it, meaning that every epsilon would have a different variance. Well, that assumption would be different from them having the same variance, okay? So for example, if I assume the same variance assumption, okay, if they do have the same variance, okay, under certain assumptions I could say that this thing here will be an unbiased estimator. So that means that the expected value of epsilon of sigma square hat will equal to sigma square. And that's what statistical property 3 tells you. It tells you under what conditions, under what assumptions is the expectation of the residual sum of square divided by n minus 2 going to equal to sigma square. Okay? That's what statistical property 3 is about, right? It's just telling us that under those assumptions, like if we assume homoscedasticity, if we assume exogeneity, if we assume a linear model with mean zero error term, then this measure here, which will also be a random variable, every time you change the sample, you will get a different variable, will be unbiased estimator. Okay? On average, it will give you the truth. And that's statistical property 3.